Hello students, in this video we'll see how to parameterize a hypocycloid. A hypocycloid is the following graph. This is my x-axis and this is my y-axis. I have a circle of radius a, so this length over here will be a. And then what I do is I roll a smaller circle of radius b inside the circle of radius a. So I have a smaller circle over here, and that's rolling inside the big circle. And it rolls, and let's say that this is a point over here on my hypocycloid. Let's say that, and what I'm going to do is this. So I'm trying to parameterize this hypocycloid, so I'm tracing the trajectory of a point on this curve over here. So let's say that, for example, the point is over here on my hypocycloid. And the idea now is that the length of arc from where this intersects the circle, this length of arc over here has to be the same as this length of arc over here. And that's the entire idea behind the problem. Because if it rolls that far, and this is a point on the hypocycloid, you're parameterizing in terms of how far you've rolled like that. And so now what I'm going to do is this. I'm going to draw a line that goes through the center of that circle. That's the center of the circle. So this length over here is b, right? And that's also a b. And so now what I want to do is I'm going to draw a line parallel to the x-axis. So this is parallel to this. And I'm going to call this angle over here theta. And this theta is going to help me parameterize the hypocycloid. So if this angle over here is theta and that's parallel, then this angle over here is also going to be theta. Okay? Now what I'd like to do is that's my point xy. Then there's going to be this secondary angle over here. If I go down and I draw a little triangle like that, there's going to be an angle, and that angle over there is going to be an angle phi. Okay? And so what can I say? I can recast my arc length assumptions in the following way. I know that b times theta plus phi, that's the arc length over here, that has to be equal to the overall arc length, which is what? Which is a, the radius of this thing, times theta. That has to be a times theta for our configuration to work, for that to be a point on the hypocycloid. Good, so I'm able now to solve for phi. What does this tell me about phi? This tells me now that b theta plus b phi is equal to a theta, and therefore b phi is equal to a minus b theta, and phi therefore is a minus b over b theta. Okay? Now, what is the coordinate of my point on the hypocycloid? Well, let's do this over here. So if I drop down a perpendicular over here, well, what is this overall length of this hypotenuse? That length over there, if the whole length is a, I'm really just subtracting off this. So this length over here, this hypotenuse over here, has a length of a minus b. So I add it to b, I get back to a. So this length over here is going to be a minus b cosine of theta. And this dotted line length over here is going to be a minus b sine theta. So now I'm in the position to write down what our point looks like. So here's our point, xy. Well, what is the x value on my hypocycloid? The x value on my hypocycloid is relative to this angle phi. So I have to go over a minus b cosine phi. So a minus b times the cosine of theta. And then I have to go over a little bit more what? A little bit more over to get to that point. And how much more over do I go? I go this distance over here over, which is what? This, of course, the hypotenuse is a b, so that extra distance is b times the cosine of that angle. So b times the cosine of phi. And what will the y-coordinate of the hypocycloid be? Well, I would have what? I would have this a minus b sine theta, a minus b sine theta, and then I'm going down. So I'm going down by how much? I'm going down by b times the sine of phi. So that length there is b sine phi. So I'm going to subtract off b sine phi from this. And now I know what phi is, because I've solved for phi using my arc length assumption. So by the arc length assumption, I can now write down the parameterization of my hypocycloid. It's what? It's a minus b cosine theta plus b times the cosine of phi, which is a minus b over b times theta. And y is equal to what? Is a minus b cosine theta minus what? Minus b sine of a minus b over b theta. And this is my parameterization. This is the parameterization of a hypocycloid. The key ingredient to this proof is the fact that once you have swapped this arc length of theta plus phi on the smaller circle, I have to subtend the exact same arc length because that length of arc is the parameterized measurement that you're going to use relative to the radii of both these circles. Thank you very much.